Okay, so my atomic clock says that it is just the time to start. So welcome everybody on the next webinar from ailelabs.pl. And today I am more than happy to have a fantastic guest, to have a master of the metrics and probability approach to project, Daniel Vacanti. So welcome him wisely. And we are going to ask him a couple of tricky questions around metrics. And in the second part of the meeting, we ask you or encourage you to share your questions, to ask your questions, because it is actually a pretty unique opportunity to have Dan answering it in person. So welcome everybody, and let's rock and roll. Dan, do you want to start with some brief hello?
Yeah, and hello to everybody. I just want to say how happy and honored I am to be here, and thank all of you for taking time out of your day to join as well. I especially appreciate you. This is maybe an awkward time for some people, so you making it convenient for me. I know we've been trying to get this scheduled, I think, for several months. And so I'm glad that it finally worked out, and I'm happy to be here, and I'm excited for the session. So thank you, everyone.
Okay, so let's rock and roll with question. And the question is, what you should pay attention to while introducing metrics to the team and to the managers? Is there any differences, or actually it is just the same? Do you distinguish these two groups when you start talking and introducing metrics to?
Yeah. You told me they were going to be hard. So I'll start with the easy one first. You know, if we're talking about a team, we're talking about introducing metrics for a team. Anybody who has followed my work knows that I'm very vocal about this. I'm very biased about this. For me, the number one metric that you should be paying attention to as a team is something called work item age. It's not, it's not a metric I think that is really well known in the industry, in wider agile industry specifically. In Kanban, it's kind of known, but it's not really well known there. But work item age is just a measure of how much time has elapsed since this item has started, since a particular item that we're working on has started. Because if you're just paying attention to how long it has been in progress, how long have we been working on it, there's a wealth of information that you can get just off of that one metric. And we can maybe talk a little bit later about leading versus lagging indicators. I'm not a big fan of that type of language, but if there is such a thing as a leading indicator, age is it. You know, if you want a signal as soon as possible that maybe things aren't going the way that you expect them to, where that's going to show up is age. You know, the item's just going to be taking longer. If you wait for some of these other metrics like cycle time and throughput or whatever, by definition, the item has to have finished before you get that signal, which is too late. By then, if it's taking too long, you wait till it's finished, it's too late to get that signal. So for me, by far and away, the number one metric that I would look at is work item age for the team. Now for management, the reason I think that one's a little bit harder is because I think it really depends on what question managers are asking. Generally speaking, management wants to know when will it be done. I mean, generally speaking, they care about predictability. So if that is the case, age doesn't really mean anything to them. They don't like, I don't care how long this thing has been in progress. You know, I want to know, hey, we've got this backlog of items. When will all these items be done? You know, in that case, if that is the case, right? And I'm making a big assumption here, but if that's what management really cares about, then the metric you really need to be tracking is throughput, is something called throughput, and probably throwing that throughput into something that's known as a Monte Carlo simulation, so we can start modeling, you know, roughly when we think these items will be done. The advantage of that is the Monte Carlo simulation will give you an understanding of risk. Will give you an understanding of, you know, hey, things are going the way that we expect them to, or we have an X% chance of things working out the way that we expected them to, or we have an X% chance of them not working out the way that we expect them to. And depending on your risk level, you might need to make adjustments to your plan based on the results of that simulation. So I waved my hands a lot there. Both of those things, we could probably spend the rest of the hour talking about either one of those things, I think. But hopefully that gives a nice overview.
Yeah, definitely. So basically, you almost also answered our next question. So it was about, how do you identify the needs of the team when you first join, and then what you pay attention during the first implementations, and where you would suggest to start. So I guess you just answered all of these. So the next one would be, do you have any suggestions for visualization of the metrics? So are there any tools you recommend, or what to look for? And
Yeah, well, again, I'm very biased on that too. One other thing I would say about the introduction of metrics is, there has been, I was going to say there's been a lot of bad advice. That's kind of harsh. I don't mean it to be that. I mean, I kind of do. But there's maybe been some suboptimal advice, especially around how to get started, with metrics, especially just around process in general. If you're doing a daily scrum or a daily stand-up, and hopefully you are, so many teams follow the prescription of the 3 questions and things like that. And not that that's inherently bad, although it really kind of is bad. But from a metrics perspective, there's no actionable information about the 3 questions. And to me, this is where age really helps. This is why I talk about using age first, as the introduction, because it can really help focus those types of conversation. If what we really care about coming out of our daily is a plan, hey, how are we going to self-organize? How are we going to self-manage for today? If that's what we really care about, for me, age is the metric that will say, oh, these items are in trouble versus these items are in trouble. I don't necessarily care who's working on them. I know that sounds bad, but I don't, because we're a team, right? We're a team, and if one person's in trouble, one item's in trouble, then the team's in trouble. And as a team, we need to figure out how we're going to do that. And the way we get that signal for whether in trouble or not is age. So, kind of close the loop on that. Hopefully, answer your second question, maybe a little bit more.
Yep.
In terms of visualizations of these metrics, again, very strong bias. I think I'm even wearing my company shirt. I created a tool called Actionable Agile. My motivation for creating this tool, because what the world needs is yet another tool, right? Of course not. That's not true. But the reason I created this tool was my growing frustration with the lack of the visualization of these metrics in the more popular tools. When I started, there were names like Rally and version 1, right? Names you don't really even hear anymore. I don't even know if they still exist. Somebody can tell me if they still exist. But you had Rally, you had version 1, you had Jira, and their visualization of their metrics were either non-existent or poor or incorrect. Just even incorrect, or some mixture of all 3 of those things. So that's why I kind of set it out as my mission to kind of correct that. So, but now you have essentially Jira and Azure DevOps seem to be kind of like the 2 big players. You've got some other side ones like Trello, although Atlassian took over Trello and things like that. But it's kind of startling to me that the big tool players really don't want to focus too much on the visualization of the metrics. That's not where they're investing their money. I guess it's great for me, but it's kind of bad for the industry. And I'd much rather see the industry succeed, if I'm being completely honest. So I know it sounds like a selfish, and it sounds like a shameless plug, but from a visualization perspective, the Actionable Agile analytics tool that we created, I think is the best on the market. I believe to be the best on the market for metrics visualization. Apologies for how arrogant that sounds. I know it does. It sounds bad, but.
Dan, do you make any experiments with totally new metrics, which are not widely known so far? You create new stuff, you experiment around that.
Not, I mean, so metrics themselves, not so much. Although I think there's the one problem. I'm going to give you two answers. The one problem that I think that Agile hasn't solved yet, and I'm surprised they haven't solved, and maybe there isn't a solution to this, but there really hasn't been any talk about the financial metrics of Agile, right? Now I know like beyond budgeting kind of touches on this or whatever, but like if I'm a CFO and I'm investing in a full-blown Agile transformation, what are the metrics that I can look at in terms of has that helped my top line, has that helped my bottom line? And for the most part, the Agile industry has been, well, just trust us, you'll get better. Right, but there's no real hard metrics around that. So for me, an exciting, probably very fertile area of where we can explore new metrics would be that more kind of like things like how do I turn cycle time into dollars and cents or euros? Sorry, euros and cents. How do I turn throughput into dollars and cents? Right? How do I do that? That's kind of exciting. So in terms of new stuff, that's where I would be looking in the future. But in terms of like current, I'm not really looking at new metrics, but I'm looking more at different ways to visualize the metrics that I talk about, different ways to help people understand the impact of these visualizations, like for example, probabilistic thinking versus deterministic thinking, things like that. So it's not really new metrics, it's new ways of educating or getting people to think differently about about these problems. So I don't know if that helps or not. And again, I'm kind of rambling, so I apologize. I'm sorry about that.
All right. So maybe when we are talking about new things, so do you see how artificial intelligence in general, like machine learning and stuff like that, can help us in terms of metrics?
Absolutely. Yes. It's not to give away too many trade secrets, but it's something that we've been talking a lot about in Actionable Agile, because it's one thing to present the data to the user. Yes, we've come up with a great visualization, so it's one thing to present that data. It's quite another thing for people to interpret that data and turn them into actionable. That's why we call it Actionable Agile. Actionable activities. So that's to me one place where artificial intelligence and machine learning, I think, can play a big role. I mean, we obviously there's still some limitations to that, but just some guidelines in terms of, hey, this looks interesting over here. This stuff on the scatter plot, this looks interesting over here. The stuff on your aging chart, this looks kind of interesting over here. At least prompting the users in terms of of where to look. I have no doubt that is going to play a bigger role in some of these things, but that's not to diminish the whole human side of this too, right? Not to hedge my bets too much, but at some point there probably still going to need to be some human somewhere that is driving the actual actions. But yeah, I mean the opportunities I think are almost endless in terms of AI and machine learning for sure.
Thank you. It used to be told that the trends matters, which we should look on not on the metric, not on the points, but on trends. And what is your opinion? Is it true, or actually we should look on the whole data sets in general and not focus on trends only?
Yeah, in my opinion, trends are dangerous. Let me take a step back first and say, I'm a big believer in, before you even start calculating numbers, getting into more what I call quantitative analysis, or what is called quantitative analysis, and start calculating a whole bunch of numbers. I'm a big believer in taking a step back and just looking at your data and, is there a story that your data is telling you? And that could be, hey, maybe there's a trend here, maybe there's an outlier here, maybe there's whatever. The thing is that language is very very dangerous once you get into the more quantitative side of the house, because that's more qualitative analysis. Once you start wanting to turn this into hard numbers, to say, hey, there's a trend here is dangerous, because all data has a variation in it, right? So I mean, like if you look at your cycle time data, nobody is going to have a process where every item took exactly the same amount of time to get done, right? There is going to be just natural variation in differences in how long it takes for certain items. And so the reason the language of trends and outliers, whatever, the reason those are dangerous is because what we really need to understand is that trend that we think we're seeing, is that just natural variation that's happening as part of our process? Is that outlier we're seeing, is it really an outlier, or is it natural variation that's occurring as part of our process? And so that's, to me, that's the more important question, is, to put Dr. Wheeler's, if anybody's familiar with Dr. Donald Wheeler, to put his language on it, it's all about separating out signal from noise. So many times people want to see a trend and they want to treat that as signal. Oh, hey, look, we're getting better. Oh, hey, look, we're getting worse. You're probably not, because that's just natural variation in the data. So that's why, yes, I mean, in general, I think it's a good idea to look at your data and say, hey, is something, like I said before, something interesting happening here? But then very quickly checking that with, let's put some harder analysis on it to say, well, is something really happening there, or is that just natural variation in the data?
Okay, so a bit different topic, but a lot of people are talking about agile at scale. So when scaling up, or in any like scale environment, when multiple teams are working on a product, and what kind of metrics you would see there, and how to also use the existing metrics per team to scale it up and see some high level picture of what's happening. Do you see any? Could you guide us here?
Yeah, it might seem overly simplistic, and maybe it is, maybe it isn't. But I'm a believer in. I don't know if anyone's heard this expression before. It's an expression in English. I don't know how well it translates into Polish, but in English we have this expression. It's turtles all the way down. I don't know if anyone ever heard. It's turtles all the way down. So for me, the metrics that are important at the team level are the same metrics that are important at the project or portfolio level, are the same metrics that are important at maybe even the more strategic initiative level. And so it's just the basic metrics of flow that I talked about, cycle time, aging, work in progress, throughput. All of those metrics are going to be, depending on what level you're looking at, all of those metrics are going to be shaped by the context of that level, but they're all answering the same questions. So are there potentially different metrics that you need to look at in addition to the basic metrics of flow at those levels? Maybe, probably, but at a minimum, I'd be looking at those, at those flow metrics. So, like I said, I know that sounds overly simplistic, and I know that kind of flies in the face of what a lot of people say. But I just think flow is flow is flow is flow. I don't care what level of the organization we're talking about. It's still flow, and so those metrics are important.
Okay, thank you. Probability sometimes, predictability, sorry, is defined sometimes as a number of times we plan something versus we delivered something. And what do you think about such kind of a definition of predictability?
Well, yeah, you kind of had a Freudian slip there, right? Because because when we talk about predictability, what we're really talking about is probability. I mean, and so the whole plan versus actual, it's like we said we were going to get 12 PBIs done in this sprint, but the team only got 11 PBIs done in this sprint. So therefore, this team is not predictable because they did not do what they said they were going to do. Well, again, and I hate to sound like a broken record, but I don't. Not only do I not, but none of you do either. We do not live in a deterministic world. We do not live in a world where, I can say with exact 100% certitude how much stuff I'm going to get done 14 days from now, or 30 days from now, or even 3 months from now. That world just does not exist. What I can say, though, is from a probabilistic perspective, what's the range of items I think I can get done, and what are my chances of hitting that range? So when we talk about predictability of the team, that's what I'm more interested in, is what's an acceptable level of risk, and are we managing that risk properly? So even though I wanted to get 12 PBIs done this sprint, 11 PBIs was in that range of acceptable risk. So from that perspective, the team was predictable, because we still delivered within that range of risk. So yeah, the like plan versus actual, I think actually moves us backward. It doesn't help us. It doesn't help us go forward, because it keeps us rooted in that kind of deterministic thinking that, we need to hold teams accountable, and they need to absolutely, with 100% certainty, say what they're going to do. That's impossible. That's just not the world we live in. So let's forget about that, and let's embrace this idea of, hey, there is uncertainty. So let's talk more about how do we quantify that uncertainty and manage risk based on that uncertainty.
Okay, so we have one more question, but it's a bit, well, let's see. So there are teams that work in iterations, and then there are teams that don't work in iterations. So from metrics perspective, do you treat them differently, or there is some other areas that you should concentrate when dealing one or with the other?
From a metrics perspective, no, I don't think they're treated differently. The questions that you might ask based on the metrics that you're getting off of both of those might be different, but the metrics themselves aren't different. Now, for a team that's working iteratively, you'll almost certainly see a lot more batchiness in the data, and hopefully that will show up in whatever visualizations that you see. And so, that would cause, for me, some questions. Is this batchiness of our data helping us or hurting us? Are we able to answer the questions that we want to answer? Maybe yes, maybe no. The same thing with flow. Same thing with teams that work in more continuous flow. Batches in and of themselves are not necessarily good or bad. Again, it depends on your context and the questions that you're wanting to answer. So whether you're working in iterations or sprints, or in a continuous flow environment, same thing. If I can do another shameless plug, hopefully this is not too advertising, but I'm also involved in a community called Professional Kanban. Called ProKanban.org. Stands for Professional Kanban. ProKanban.org. And at ProKanban.org, we just launched a flow metrics for Scrum teams class, where we talk about that. I mean, just because you're doing Scrum doesn't mean you can't look at flow metrics. I would argue quite the opposite. I don't know how you're successful at Scrum without looking at flow metrics. But so yeah, I don't think just because you're doing iterations or not doing iterations, I don't think that changes the metrics at all.
Right.
I have one more question. If you start discussing that we are going to look at the throughput and this kind of a metrics of cycle time, very often actually you can hear the answer, okay, but then actually the items which we are working on should be the same size, because then we can look at the flow. So how do you approach these statements that if you hear, okay, but our work is not the same size, so we cannot use metrics?
Yeah. Flow theory, I'm going to give an academic answer, and then maybe all of you could help me out with more of a people answer. But from an academic perspective, flow theory is based heavily on queuing theory, and in specifically, say, something like Little's law. I don't know how many people are familiar with Little's law. But if you go and look at Little's law, and Little's proof of the law and all the writings he's done on Little's law, he is very, very, very explicit when he talks about there's nothing about Little's law that requires items to be the same size. quite the opposite. In fact, it's one of the reasons why he talks about averages, for better or for worse. It's one of the reasons why he talks about averages. If you go even further back to people like Shewhart and Deming, maybe not everybody's heard of Walter Shewhart, but hopefully most people have heard of Edwards Deming. Not only would they say that they don't require all items to be of the same size, they would go, I think, the complete opposite and say, you can't expect items to be the same size. There is always going to be variation in size present. So so not only recognize that, but embrace it. It's like, that their whole theory of variation is this idea that, the stuff that's coming through our process is going to be of different size. That's just the way it's going to work. So that's why I was saying before, the real question we need to ask is not why aren't these things all the same size? The better question to be asking is, well, when their size is different, when is big too big? When is small too small? Right? That's the better question. It's not how to get everything to be exactly the same size. So that's my academic answer, is to say, if you look at all the theory that flow is based on, not only do they say things don't have to be the same size, in fact, they actively acknowledge and embrace the fact that they're not going to be the same size. That doesn't obviate flow. That enhances it, I think. I don't know if that helps or not.
So to summarize, we don't need to have the same size items.
Yes.
Taken into sprint or starting working on stuff.
In 25 words or less. Yes. And not only that, not only do we not need them to be the same size, we don't even necessarily need to do things like estimate their complexity or things like that. We don't even necessarily need to know some of that stuff. We don't care. We don't care that this item's an 8-point story or this item's a 1-point story. From a flow perspective, does not matter. For the most part, does not matter. So, yeah.
Okay, thank you. Marcin, anything else from our side?
No, and I think Dominika raised a hand a second ago.
Yes.
So if you would have any questions, I think now it's the time that you can raise questions, and then we'll please unmute and then talk. So.
Okay.
Yeah, exactly.
Thank you.
And one question, one ask from my side. If you have a question, maybe it would be nice to turn the camera on so we can see who is asking. So we see the person behind the question. And yes, let's do it like raise the hand, and then we'll follow one by one. Okay,
Yeah, so thank you. Yeah, I'm very happy I can ask this question to you. And actually, it has something to do with both work item age metric and also with the different sizes. Because what I wanted to do, and my approach is, and once I've actually did it, honestly, I actually created the personalized on a work item graph for 3 different sizes. Because I thought, for the team, they would give them basically more time to actually be proactive. Because when you have, like you say, one item that entered the system and you've got on certain level of days this 85% or 80%, so this item always have this 20% of chance it will not follow the forecast. But when you look and this item comes to the middle, so 50%, let's say, and then you could see, we have to look at it. Maybe it's too big. Maybe we need to split. But the risk of the items actually exceeding it's double. So it has now 30 or 40% even of the risk that we evaluate. So we want not very stable. So I thought if we actually can react earlier, it will be smarter. So if we have a percentile of 85% for an item that is, let's say, our small estimates, if we're just 3 different, then we'll see it comes to the 50% of that quicker. So we have more time in our iteration to actually do something about it. So I thought, is it too much? Is it overdoing? Or is it, because I thought I also don't want to really come into this, but from the perspective of really looking into the sprint and seeing where we are and what we can actually do, because I really love the approach that being proactive, not looking after what happens later. So what do you think?
Yeah, no, I mean, so in general, I'm always for. I'm generally for trying to get those signals earlier. So I mean, so I love the idea of anything we can do to get the signal earlier. The only thing that I'd want to know, and I'd have to sit down and maybe talk to you a little bit more, is we have to be careful not to intervene too soon, right? We have to allow the natural variation, of our system to occur, because we don't necessarily want to go in and break down an item that maybe didn't necessarily need to be broken down. I don't know. I'm maybe kind of talking myself out of this, but so. Yes, I agree with the approach of, hey, if we can find a bigger signal, an earlier signal, great. But I don't want the team distracted by, like, for example, we pull the PBI in, it gets 1 day old. Well, that's too old. It's been in progress for 1 day.
Yeah.
We need all swarm on it and break it up and things like that. There needs to be some reasonable amount of time that has to elapse before we really know, hey, is this thing a problem or not?
Yes, I think, yeah.
And so that's just the only thing that I'd want to understand a little bit better. So yeah.
Okay, yeah. Thank you. Because I thought this intervention maybe also asking if someone needs a help with it, not necessarily breaking it. So then this was kind of my, but yeah, thanks. Thank you very much.
Well, and that's the thing. I mean, especially if we're doing something like Scrum, and we are doing 2-week sprints. If we're doing something like Scrum and doing 2-week sprints, if a developer is working on an item, if a developer pulls an item in, and that developer has been working on it for, say, I don't know, even 2 days. I mean, chances are, I think this is to your point, chances are after 2 days of work, you should have a pretty good idea of, hey, is this thing too big or not? Because two days out of 14 days is actually a significant amount of time. So yes, I mean, at least asking those questions is, I think, as early as possible is important. Hey, does this, based on what we know about this right now, does it need to be broken up or whatever? It's just, like I said, what is that right amount of time, before we start asking those questions, I think is key.
All right. Thanks, Daniel. Thanks, Dominika. So on the list, I think it's alphabetic, but Jerzy, now it's your turn.
Okay. So thank you very much, Daniel, for your really fantastic answer. So it was really great and love to meet you from time to time. And for the beginning, I have 2 questions. So one is more, let's call it a technical one. And the second refers to what you said previously in the beginning, that how to make the people think a little bit different. Yeah. So the second question would refer to this point, but I will start with this more technical. In your books and in practice, you are applying these percentile lines for the forecasting work items. And my question would be, if we in PMO have the data, historical data about the project, so our work items are not just the small user stories or the epics, but the whole project. And we can divide this project based on the duration into some, let's call it classes. So if such projects belong to the class that takes, let's say, more than 150 days, and we have the class of small projects, something like 50 days, something like that. So the question would be, what's your opinion about using these percentile lines for forecasting the projects? Not these small pieces of work, by the whole projects. If it's worth to do this, or what points, what topics can be a challenge for using these percentile lines for the project's estimation. So what's your opinion on that?
So yeah, so can you? Absolutely. In fact, I was just revisiting some notes. It's funny you asked this. I was just revisiting some notes from a client that I worked with several years ago. that did exactly that, right? And it was at the PMO level, and they were tracking cycle time at the project. For every project that moved through the process, they were tracking cycle time, and they had an 80th percentile, and their 80th percentile was 10 weeks or less. So these bigger projects, we're not talking about stories or tasks at this point, right? And so they had an expectation of projects that moved through taking 80% of them taking 10 weeks or less. And there's no reason why you couldn't. I mean, could even segment that further into small, medium, and large projects if you had the data to back it up, right? A lot of times that potentially is counterproductive, but if you have the data to back it up, there's no reason why you can't. So can you do that? Yes. If it were me, I'd probably also want to back that up with some type of Monte Carlo simulation as well. So the project itself can be broken down into smaller stories and things like that. And we run a Monte Carlo simulation on how long it would take to get all of those stories done. The reason I like the Monte Carlo simulation is because that's something that we can be doing on a more continual basis as a project's being worked, as we discover more stories, as stories get taken away or whatever. We can constantly be doing more of a continuous forecasting and constantly updating that Monte Carlo simulation. And I think the fidelity of the signal might be a little bit better. But to directly answer your question, there's absolutely no reason why you can't do what you're saying.
Okay, thanks a lot. Truly speaking, I love this idea of supporting this with Monte Carlo, and your point that it enables using more data that we can reach on the way. Perfect. Thanks a lot. And second question is, as I said, connected with your point at the beginning. So how to make the people think a little bit different regarding the metrics, regarding the flow. Okay, so of course, I am a big fan of this flow approaches, and together with my partner, we are just started last year to deliver a simulation, a team flow simulation, project simulation, and also portfolio for teams and PMO simulation built on Kanbanized platform. And in our opinion, this simulation are really a fantastic stuff. The only small problem is that, well, the executives and managers are not thinking in the same way. So then the question to you would be, what would be your recommendation for us delivering such a simulation or promoting such a simulation games to make these executives, managers, and also the teams to be really interested in such way of learning and experiencing the flow? So what would be your recommendation?
So my standard answer to this, if I had a great way of talking to executives and getting them to understand what we're talking about, if I had a great answer to that, as much as I love all of you, I probably wouldn't be talking to you. I'd be sitting on a beach somewhere counting all my money, because that's kind of the holy grail, right? That's so my very, very blunt answer is I really don't know. I don't know the secret sauce that you can talk to executives. What I can tell you, what I can say is I normally, especially if we're talking about executives, where I have the most success is, like I said, couching it in terms of risk. Usually executives, they don't understand, or I should say that makes them sound harsh. They're probably intelligent. That's probably why they got to where they are. But they usually have some understanding of risk, right? If you can couch things in terms of risk, especially like public companies. Like if you're working with the CEO of a public company and you were to ask that CEO, hey, what's your stock price going to be exactly 1 year from now? What is your stock price going to be exactly? And the CEO probably won't be able to answer exactly, but he or she probably be able to give you a range. Hey, we, given everything that's going on, we expect it to probably be right. And for me, it's kind of the same thing here. It's just strange for me that executives really kind of understand uncertainty in other aspects of the business, like what's going on in the macro economy. what's going on with the stock market, what's going on with whatever. They kind of understand risk and uncertainty there, but for whatever reason, when we start talking about agile software in particular, they think that can be deterministic. If we can somehow, and that's why I like this probabilistic approach, because I can start talking about risk. It's like, here, I can't tell you exactly what's going to happen, but I can give you a model that will help you understand your chances of being right or being wrong. And so let's talk about what is that acceptable level of risk and how we might need to change our plan or execution based on whether that's too much risk or too little risk. So I know that's not a satisfactory answer. It's not a satisfactory answer for me either. But I really do not know what the like I said, the magic words are to say to get people to understand. I don't know.
Okay, thanks a lot. At least I have some inspiration. And if you would come to this magic sauce answer someday in the future, please share it with me. Thank you in advance.
I would give it to the world for free. Like if I discovered a cure for cancer, I would just give it to the world for free, for sure.
Okay, thanks a lot.
Thank you.
All right. Thanks, Jerzy, for the question. Thanks, Daniel, for the answer. Now, Krzysztof, if you're ready, please unmute.
Yes, I'm ready. Hi, Dan. You know, when we talk about Agile, we talk about unknowns. We can't really predict the project, right? That's why with Agile, we have many unknowns. And then on the other side, we say, let's do simulation, let's gather data. But that data is only as good, as what we get. And we had this waterfall approach that we tried to find out everything, to build those simulations and be accurate. Here, I have a feeling that when we build our models, when we show the metrics, they, as you say, there's the probability will not deliver because actually the scope, the idea, and what I very like what you said, the financial metrics, we don't know when we are going to finish the project, right? Because I think like a metric of ROI, return on invest, when the project reaches that threshold, we can terminate the project. And we don't know when that is going to happen because that's the idea of the product owner. When he sees what he gets, he can say, okay, I'm done, or let's move in the other direction. Then what I wanted to ask you is, with this big amount of uncertainty, which is built into Agile, we got a huge mismatch on the expectations we get from the metrics and from the simulations. Unless we do really close to waterfall, then we are not doing Agile. And the second question I would ask is, where do you fit those metrics in Agile principles? When we look at 12 Agile principles, I think there is nothing about metrics there. How do you correlate those things?
I think you're right. On the second point, I think you're right, and to me it's one of the downfalls of the Agile industry. I think you're right that it's almost, I know this sounds bad, but it's almost like too human. We put like too much emphasis on humans, but the problem with that is humans come with biases and deficiencies and whatever. Just like anybody else, right? I mean, that's the problem. And so, if we can counter that with some objective information, I think we'll be that much better. So, for the second point, you may be right. I'm not sure that the data and metrics is mentioned anywhere in either the Agile Manifesto or the principles behind it. Why? Like I said, I have my guesses, but I'm hoping to change all that. For the first part of the question, I don't know if you've seen my hurricane talk, where I talk about how, because I live in Florida, and as you can imagine, we get hit by hurricanes every so often. And it's a fascinating case study. For me, it's a fascinating case study about how they forecast hurricanes. You want to talk about a complex environment with uncertainty, right? Talk about hurricanes. Add on top of that, that hurricanes are literally life and death, right? If you get that forecast of the hurricane wrong, people potentially will die, and so you're right in that. The metrics are only as good as our model. They're only as good as the data that we're getting. They're only as good as all of that stuff, which is why the National Hurricane Center in the U.S., the place that that forecast hurricanes here, which is why they're constantly measuring data, constantly grabbing data, and they're updating their models. They're continuously updating their models based on that new data that they're getting. That's how they forecast hurricanes. They don't do a bunch of planning 6 months out and say, okay, this is exactly where the hurricane's going to go. No, they say, hey, based on the information we have right now, this is what we think is going to happen. That's 4 hours from now, that's going to change. And we're
I like the analogy.
We're going to put out a new forecast. 4 hours from there, it's going to change, and we're going to put out a new forecast. And that's so you're absolutely right. But I don't think that means necessarily going waterfall. I think that just means you have to understand that whatever model we have right now, probably wrong. But we can update as we get more information. We can update it as we know that sample path. Well, we will update it, and by doing that, hurricane forecasting has become extremely predictable. People might say that it still isn't, but I mean, if you think about how complex hurricanes are, that they can even do what they do right now is, I think, miraculous. So anyway, I hope that helps.
Thank you very much for your answer. I like the analogy to the hurricane. Thank you.
Thanks a lot, Krzysztof. I think when it comes to the agile principles, the last one, when they are asking the team to self-adjust. So I think this is the metrics are the tool for this. So how can you adjust something when you are not getting the data and working on real data just on a hunch? So,
well, yeah, but I mean, don't most agile teams, when they get to the retrospective, it's more like, well, I felt it when the last 2 weeks went this way. I felt, right, and I'm not saying feelings are wrong. Well, I mean, they can be. Or sorry, I'm not saying feelings are bad. Maybe I should say it that way. I'm not saying feelings are bad, but yeah, I mean, I think they have to be tempered by some type of objective view.
Yeah. That's what I wanted to bring to the table. All right, Łukasz, if you're ready, unmute and ask your questions.
I'm ready. Hi. So the question is about dependencies in the context of supporting transparency around dependencies, which quite often are kind of elephant in the room. So while some tools, the portfolio management tools, offer some visualization, like chart graphs, forest graphs, whatever, I'm rather interested about some, from metrics perspective and simple, how to visualize the numbers, So what's your take on this? And
most, I have an opinion on everything, as you know. The problem with dependencies is not necessarily the dependencies themselves. The problem with dependencies is I don't think people really understand again, I'm going to talk about risk. From a risk perspective, how costly a dependency can be. Because if you have team A that has an 80% chance of being successful, but team A is dependent on team B, and team B also has an 80% chance of being successful, well, that doesn't mean that we have an 80% chance of being successful, right? Those probabilities are multiplicative, and then if we add another dependency and another dependency and another dependency, it's exponential, right? I mean, our risk doesn't scale linearly or even doesn't scale at all, right? It scales, exponentially. And so to me, that's the biggest problem with dependencies that people really don't understand, especially when we talk about these other tools that visualize dependencies is, it doesn't take very long for you to get pretty close to a 0 chance of being successful when you have this, this chain of dependencies. And so that's what I would like to see a little bit more when we talk about tools and how we visualize dependencies and things like that, is as these dependencies grow and as they kind of proliferate throughout the organization, what does that really do in our predictability? I mean, we're doing all this upfront planning, we're doing all this estimation, we're doing all this whatever, but because we've got all these dependencies, honestly, our chances of being successful are essentially 0. I don't know if you see what I'm saying. So, so for me, everybody talks about managing dependencies, and I don't know that you really manage dependencies. For me, it's more about eliminating dependencies. I like to say, and I know this sounds simplistic. It's easy for me on a Microsoft Teams call like this to say this, but the solution to scaling is to not scale, right? I mean, that's, because once we start getting all these dependencies in place, our predictability is going to go out the window. I don't know. Does that answer the question? I don't know if that helps or not. But,
Yes, somewhat, but also I'm interested in, any tool or, any kind of metric, because I agree with you that, eliminating dependencies is like the best way, but like to raise the topic, right, to spark some discussion about dependencies, maybe there could be some, KPI indicator, that, there is something, happening and we should,
yeah,
focus on that area.
Yeah. I don't know. I'm off the top of my head. Nothing really comes to mind. The one thing I was thinking about that I'm not sure really relates to what you're saying is, so when I say eliminate dependencies, I'm not necessarily, because people might say, well, that's going to require a reorg, or that's going to require re-architecting our system, or that's going to require. And my thinking with that is not necessarily. So I don't know where this came from, and I know Scrum says this. But talking about optimal team size, it has to be around 10 people or whatever. And for me, one of the best ways to eliminate dependencies is just combine teams. If I could share a screen, I don't know if I can share a screen. I can show you a screen of a team I worked on. It was 60 people. And we didn't arbitrarily break that down because somebody somewhere said an optimal. And that was one of the best ways to eliminate dependencies. Didn't require a reorg, didn't require re-architecting, right? We just started combining teams. I'm not saying that's what you should be doing. I'm just saying there are probably more creative answers to this than what most people are thinking about. So.
Yeah, got you. Thanks.
Sorry, I don't have good answers. I'm sorry.
Yeah, fair enough. And by the way, great work with Actionable Agile tools. So you are fully justified to be, proud and biased.
Thank you very much for that. Thank you so much.
All right, thanks, Łukasz. And the last person who rose hand is Wojciech. So if you're ready, please.
Yeah, I am ready. I hope you can see me. Okay, hello everyone. Thanks for the first part. That in fact some of my questions was already answered, but I have one question regarding aggregation functions, because when I am going for some tools and in general the data, I can see that most popular value is arithmetic average, sometimes with median. But for example, from the experience in life science part, I am more familiar that geometric mean is more resistance to outliers. And I'm wondering why, for example, here it's not so often used.
Okay. Well, I mean, okay. When we talk about descriptive statistics like average, like standard deviation and things like that. I absolutely agree. There's only so much information that you can get from that information, and it's usually not very good. And like you said, it's easily biased, easily influenced. That's why I'm not a big believer in those types of descriptive statistics even at all. Right. That's why I kind of like to look at the data holistically, and if we have to segment the data, just using the standard percentiles rather than any aggregator function. I don't know if you see what I mean, because I don't necessarily care about like a mean plus or minus a standard deviation, and I don't care about whether the data is normally distributed or not. I don't care about any of that. I have the data. I can segment it by some very, very basic percentiles and start getting some information there. So I don't know if I'm answering your question or not, but I think any of the descriptive statistics, or I think you call them aggregator functions, any of those are very limited in their actionality. I don't know what the right word is, right? Just by looking at an average, just by looking at a standard deviation, really doesn't tell you anything, and you probably shouldn't be taking action just by looking at those things. So I'm sorry, the one that you suggested, which was better, was what? I'm sorry, I've already forgotten which.
Geometric average.
Yeah. Again, I don't know. I don't know. I think my answer stays the same. Forget about the descriptive. Forget about trying to summarize your data into one measure. I like to look at it holistically and just try to segment based on my understanding of the holistic data. So,
okay, thank you. But this was a quite good answer for me. It dropped quite nicely, and yeah, it's helping me. So thanks for this.
No, thank you. Yeah, I think especially I don't know what it's like in Poland, but in America when we're taught statistics, we're taught all these kind of standard statistical functions, like average, standard deviation. We're taught like standard distributions, like normal distribution and log normal distribution and all that stuff. But as most of you probably know, those things, they don't occur in the real world. Those tools, those mathematical tools that we've been given, they're literally shortcuts that were developed back in the 1800s and early 1900s because they didn't have computers, right? Remember, they're doing all these computations by hand. So essentially what they did is they came up with shortcuts to make the mathematics a little bit easier. Because we have computers, we don't really necessarily need those shortcuts anymore. We can just plug our data into a computer and it can crunch all the numbers for us. So, the idea of, any type of distribution or descriptive statistics, the usefulness of those, I think, very, very quickly go away. That's my opinion. That's my opinion.
Great, thank you.
Thank you.
Okay, thank you very much for all the questions. I guess you have more questions, but we don't have more time, unfortunately. So I would like to thank everybody for this time that you spent it with us, and especially for you, Dan, that you dedicated your time with your busy schedule to be with us and answer all the questions. Thank you very much, and I cannot say how happy I am after looking at all the speeches and have this opportunity to have you on our webinar.
I want to say thank you so much for everybody joining. I want to say thank you too for letting me speak English. If I had to speak Polish, this would be a very by the way, the only Polish I know, and forgive me, my pronunciation is terrible, is gdzie jest łazienka. That's the only Polish.
Wow. That's very nice.
It is.
So it would be very short conversation. So thanks everybody for taking time out. I thoroughly enjoyed the conversation. Tough questions, you ask really hard questions, but
yeah,
but I enjoyed it.
Tricky question and solid answers. Thank you very much.
Yeah.